Now, we move on to the next slide, wherein some other symbols are mentioned coming under the heading of modifier symbols. That means, in addition to the 14 main symbols, what we have seen in the earlier slide, these symbols are called modifier symbols because these symbols modify either the shape of the tolerance zone or the value of the tolerance zone. Out of all the symbols, the most common symbol is this one, that is M symbol, standing for maximum material condition. The other symbols like L, which is signifying least material condition, the P, T, F, etc. are used a bit rarely, and of course, the dia symbol is again common in some of the orientation parameters and location parameters. We will discuss the individual meaning of each symbol as we go along our discussion. In addition to the modifier symbols, we have yet another group of symbols called additional symbols, and these additional symbols, the sole purpose is to make the engineering drawing more neater and clutter free by minimizing your writings or what you call notes written in the drawing. There are symbols for counter bore as well as counter bore depth. Then there are symbols for countersink as well as countersink depth. Similarly, there are symbols for controlled radius, spherical radius, etc. Well, how do you denote the geometric tolerancing symbol in engineering drawing? The GD&T parameter is mentioned in the drawing in what you call a feature reference frame. This entire frame is called as a feature control frame, and it is divided into 1 or 2 or 3 or 4 or 5 compartments depending upon the symbol being used. Irrespective of the symbol, the first compartment always should contain the parameter symbol, one of the 14 main symbols what we have seen in the previous slide. The second compartment should contain the value of the tolerance either in millimeters or in inch units depending upon the overall unit of the drawing. If the entire drawing is in metric units, the value of the tolerance has to be in millimeter. If the entire drawing is in inches, then the value of the parameter should be in inches. Then further boxes contain the datums in the proper order as applicable to the parameter, controlled parameter. The first of the given datums is always the primary datum. It needs to be considered first while the part is kept on a fixture or taken alignment in a inspection setup. The second given in the order is called as secondary datum. That means it needs to be considered in the second order. Then last datum given is called tertiary datum. That means it has to be considered in the third order. One of the main important thing to be noted here is the order of datums is extremely important, and the meaning would be totally different if A, B and C are written in some other order in this example. Let me give few more examples of how the GD&T parameters are used in the drawings. Feature control frame can have 2 compartments or 3 or 4 or 5 compartments like shown in the earlier slide, depending upon what is the parameter being controlled. By now we know flatness is a form control and datums are not applicable to flatness parameter. That is why the flatness control will have only 2 compartments. The first compartment where you show the symbol and the second compartment indicating the value of the parameter. Now, look at the second example where perpendicularity control says the perpendicularity needs to be within 0.1 millimeter with respect to datum A. Then the third example here says about a position tolerance. Here there are 4 compartments. The first compartment again contains the symbol position tolerance. The second compartment talks about the value of the tolerance, that is dia 0.1 millimeter. Then A is primary datum here, B is secondary datum here. In this case, the tertiary datum is not controlled, as this particular part does not need a tertiary datum. So, depending upon the control and my application requirements, the feature control frame can have 2 boxes or 3 boxes or 4 boxes or 5 boxes, and again I repeat, if datums are mentioned, the order of the datums is extremely important. The first one we call it as primary datum, the second one we call it as secondary datum, and the third one, if it is given, we call it as tertiary datums, and they need to be constrained in the same order in which it is mentioned in the drawing. The same thing is again repeated here. The first box talks about the symbol, the second indicator or second compartment talks about the value of the tolerance. The last part of the frame talks about the datums stated in the order in which they apply. Let me show a sample drawing in which the various GD&T controls are indicated as per the design requirements. You can see the primary datum marked as A, and this particular surface is controlled for flatness within 0.5 millimeter or 50 microns. It is my primary datum, and the B is my secondary datum, which is controlled for orientation perpendicularity with respect to A within diameter 0.04 millimeters. Once primary and secondary datums are established, the other controls are added based upon the requirements. You can see the run out control of this bore with respect to B, and the holes on the pitch circle diameter are controlled for position with reference to A as well as C. So, in a GD&T drawing, the datums need to be indicated in the proper manner, and the primary datum should be controlled for form, secondary datum should be controlled for orientation. Then you add the other controls as required, could be position, could be run out, concentricity, etc., etc.